Just a couple of short announcements tonight before I introduce our speaker. Firstly, we've got two talks this month. So we've got another DevOps talk. So this is now our DevOps month, which is great because it's probably been about a year or so since we did any of these events on DevOps. So it should be quite an interesting month for us. I just wanted to, just in case some of you didn't get the email and you're interested in helping out for a teen coding event that one of our colleagues is running on the 16th and 17th of August, which is part sponsored by Vodafone. I sent an email out around mentors and people that might want to do some presentations at this event. So if anybody feels up to it, or if anybody's got kids between the ages of 14 and 19, then I'll circulate this email. I'll put something on the message board, or just reach out to me afterwards, and I'll put you in touch with the organisers. But they're looking for some help during the day. So tonight I'm going to introduce you to Matteo Emili, who I'll get this one soundbite right because I've been practicing it a few times today. But Matteo was the youngest Microsoft Most Valuable Professional at age 19, following being an MSP. So for us older generations that got ours in our late 30s, it's quite impressive. He's the founder of DevOps group. Yep. And I'm sure he'll be telling you more about it. So tonight we're going to hear from him. Am I doing deployments right? Probably not.
Thank you. I got the laptop. Thank you very much, Rich. So, first of all, welcome. And I think I'm going to bore you for the next 90 minutes talking about deployments. So, given that, first things first, this is not a lecture. So feel free to stop me anytime. Tell me if I'm wrong. Tell me if you don't agree with me. I'm more than happy to instill a conversation and start talking about things that can deviate from the topic of a session. So that would be absolutely fine. As said, I'm Matteo. I've been sticking around for the past 10 years as a Microsoft MVP, currently in Developer Technologies and Azure DevOps, Twitter, blog. Feel free to pester me as much as possible. I'm always happy to entertain questions. So tonight, deployments, as said. And this session, this is actually I think the fourth version of the session, and I kept adding more and more content because everything started from this question. Is deployment taken for granted these days? And I think so. So starting from this started with a conversation with a few friends a few years ago, a couple of years ago now. So we go on and we talk about continuous deployment, continuous delivery. We talk about better quality. We talk about pushing code quicker, better, forward to the user and bringing value. Yeah, true. These open the floodgates for a better way of doing releases, okay? Because now pretty much everybody uses a build server, because we should have a concept of automation, and because we should have a deployment orchestrator on top of it. So we have all the tools at our disposal to do whatever we want to do. But at the end of the day, I still go around and I still see Friday 5 o'clock in the afternoon releases, out of our releases for whatever reason. It's like it was big data a few years ago, Scrums even backwards. Everybody's doing continuous delivery, or at least they're attempting to do continuous delivery, but just a little percentage managed to do it, really. And it's tough. I mean, don't get me wrong, it's not easy. Okay, it's not the easiest thing in the world, especially because DevOps itself is based on those premises, and there is no formal definition of DevOps. There is no DevOps Enterprise Edition that you buy and install on your server. So it's very much a pick and choose of best practices and toolings that you might use to achieve a certain result. So from my point of view, it's pretty much two sides of the same coin here. Okay? So from one side, you've got the brownfield projects, which are usually the hard projects. Everybody just says, oh yeah, brownfield is hard. For several reasons, mainly, to me, number one here, resistance to change. The human being is naturally resistant to change. There is no way of avoiding it. We are social animals, and we tend to build on top of what we know it's better, what we feel it's better, and personal experience. So resistance to change, top problem right here. Then you also have years of legacy. It could be architecture, it could be technology, it could be people, where the same team always worked in a certain way, and then we go back to the first point. Long story short, everybody will tell you that, oh yeah, brownfield, it's very difficult. We better start from scratch, or we better start with a dedicated project where we will allocate 2 years of work, and then at the end of the 2 years, we pretty much got nothing. On the other side, you got the brownfield projects, which are usually categorized as easy. They are easy, usually, because nobody's got a very good idea of what a real mature pipeline is and does. And everybody just tries to copycat Facebook or Netflix, or just trying to throw as much technology at the problem. And everybody just tries to implement as many new techs as possible onto the new greenfield project, which by definition starts from scratch. So yeah, it is easy. And it is easy because if 6 months into the project, you realize, oh yes, I really want feature flags now because everybody's doing feature flags and we should do them as well, then it's easy to change things. You're 6 months into a greenfield project. So chances are that you delivered slightly more than an MVP. Not myself, but a minimum viable product. There is no legacy at stake here. So you can change things. You can take risks. You can make sure of implementing everything in the best possible way if you can and will and want. So those are the usual answers that I get after this short pitch in a professional setting. Oh yeah. We are not your over-the-top of choice, so you name it, Netflix, Google, Microsoft, Facebook. We cannot do that. It is too expensive to change it. It's too expensive to revamp it, to restructure it, refactor it. Can be true sometimes, but this is the worst one. Everybody's used to it, which means that this that you're putting forward is not an actual concern for us. And this is the worst, because it means that you're not accepting the fact that there is always scope for improvement. We all talk about continuous improvement anywhere. If you open on Google, you'll get hundreds of millions of results about continuous improvement. And this is an individual that just ignores that. So the reality is that when we talk about a deployment pipeline, we talk about a critical asset for a company. And again, it is a critical asset. I would put it on par with all the employee management systems and all the financial systems for one reason. This is a pipeline. This is literally a pipeline, okay? So there are similarities between civil engineering and software engineering. When we talk about pipes in civil engineering, and in this case, we're talking about energy, pretty much, we talk about an orchestrator, okay? So your Azure DevOps pipelines that move stuff back and forth and run tests and do things, it's your set of pipes that bring something, we'll see what in a second, from point A to point B. Then you've got valves, which in civil engineering terms are the same stuff as approvals. Something goes onwards of a certain point just after an approval. It can be automatic, it can be manual, it can be program-based approval, but it's still a valve. That piece of code doesn't go onwards on its journey until someone approves it. Intermediate stations, which are these ones, where, let's say, electricity is transformed from a voltage to the 240 volts that we got at home. Those are our environments. Before we bring our line of code from the source control to the production environment, which is our 240 volts at home, it goes on onto a journey. Several environments, testing performance, stability, you name it, okay? It can be all sorts of things. And eventually, we're all missing fuel. So fuel, in this case, well, you guessed it, I assume. It's our system. So our system can be compared to fuel in a civil engineering scenario. And that's true, because if you think about it, you start from raw materials, your code, which is then built as a binary. This binary is moved over via some pipes, valves, intermediate stations, and it gets into our homes or to the target production systems. It's called engineering for a reason, okay? So, okay, I'm sold. Well, hopefully. How do I start treating my system as fuel? You need two things, simple as that. You need the real cornerstone of deployment improvement, this one here. Any guess? Not Legos, but close enough. Packages. If you really want to improve your deployments, you should be able to have packages which you can move across so that you will basically forget about how should I move these artifacts across. This is tough. It can be difficult, but this applies to every type of application. Web application, mobile application by design, Windows application, MSI installers, anything really can be packaged. So a package, by definition again, and again, I'm not going to go on for 90 minutes talking about definitions. There will be demos in just a few minutes' time, but I want to set the landscape straight. A package should contain all the binaries which are required to make a system or a portion of it work, which could be your microservice, it could be your operating system, still a package. But how? My application is legacy, right? I cannot change it. I cannot start shifting this landscape, or it runs on-premise. I cannot use Azure DevOps services on-premise because, I run on-premise, and all sorts of ifs and buts. The answer here is that regardless of the technology you have, the technology you choose, what you use, nowadays we live in a technology landscape where everything is possible. So forget about runs on-premise, it's legacy, whatever. You want to package VB6 applications, you can do it. Classic ASP, go for it. All sorts of things. Again, there are many packaging solutions out there, and my favorite one, over anything else, MSDEPLOY. MSDEPLOY, this is a switch that's been around. It doesn't work, okay? This set of switches here, it's been around for, I would say, a good 15 years or thereabouts. This will invariably build this folder structure, a zip file, source manifest, parameters, deploy batch file, and a README, invariably, always, all the time for a web application in this case. Why is it cool? Because MSDEPLOY is one of the free methods for deploying to an Azure web app. First one is MSDEPLOY. The other one is a Git repository, which can do the job, and very well at it, if I'm honest with you. But for certain scenarios, it might not be recommendable. You're not just pushing the code or the binaries, you're also pushing the history of the code, so it can be a problem for certain organizations. And FTP, which, we're in second half of 2019, I'm not going to use FTP. There's no discussion about it. So this has been around forever, and it is solid enough to be used not only for on-prem, because you only need to install the free 3.5 megs package on an IIS server to get the APIs to consume this, but also on Azure by default. So your web application is becoming not only packaged, but also cloud agnostic in a matter of 70, 80 characters, give or take, for the switches up there. That's all you need. And that's an MS build argument, which means that this is running in Azure DevOps, and it does it fine. If you want to run it locally, you can do it with the MS build engine. If you want to run it through Jenkins or through TeamCD or through whatever else, take it, do it, because it works all across as long as you're using MS build. And then you need the concept of automation, because yes, I'm a huge PowerShell fan, everybody knows it, but it's extremely important to have this concept, which will apply to Bash, to whatever other automation technology, and it doesn't effectively have to be technology, because it could also be other types of automation. It's extremely important for two reasons. The first one is that automation are at the foundation of a pipeline infrastructure. We said that, right? So we got an orchestrator. What does an orchestrator do? Automates processes, so moving from A to B. And then automation ensures that there are no changes during the pipeline execution. And that's the most important one, in my view, because once something is built out of version control, it becomes immutable, which means that you will always be able to redeploy version 1.2.7 of a specific package, and you will be ensured that that package contains the same binaries from 5 years ago. And that's important. It's very important because if you have a system that you want to build with DevOps practices, with continuous delivery practices in place, having this repeatability gives you the confidence of trusting your automations. And that's key. So summarizing it, and I will stop boring you, pipelines rely on pipes and valves, approvals to ensure the desired flow. So how you use those valves affects the degree of the maturity you've got on deployments. That's literally it. Okay, once you have the pipes in place, you have the packaging in place, the variation in maturity is all down to these things. And we will see that. So approvals can be automated, of course. I'm taking it for granted. Any modern ALM and DevOps stack will give you automated approvals on a release orchestrator. It's not an exclusive of Azure DevOps or TFS or whatever else. It can literally be for anything. So those are all the prerequisites that you need. Don't need anything else, literally, to embark on this journey. So now let's take a look at some patterns, because there are effectively patterns. I've always said that it's true that software engineering can be an art, but it's still engineering. So we need to look at patterns and something that's repeatable all the time. So a small disclaimer first. All the applications featured, well, all the demos featured here will feature web applications. This was on full-fledged servers in V1. Now it's actually platform as a service. So that actually evolved. But anything that I'm going to talk about can be applied to everything. So mobile applications, you can do it. Web applications, you can do it. Windows applications, you can do it, and so on. Windows services, again, you can do it. And every type of infrastructure, I'm looking at you containers, you can definitely do those things with containers-based infrastructure. Actually, some things are very easy to do with containers. But still, it's not about technology, it's all about the patterns. So we start in a situation where we have some sort of things like that, okay? Oh, if you have any question, I will throw you that box at you, so beware. So it's all about releases. And the basic release that we see everywhere and anywhere is this. Hopefully automated, so I don't have to click release to actually start the release, but it goes on to a dev environment. The dev environment is then promoted to the QA environment after a vetting from the developers. And then after QA completes, it goes into potentially pre-prod, or if they're very agile and very lean, they go on to production. That's the usual linear deployment, right? We've all seen it. We've all been there. We've all done that. In this case, it's so simple that the development stage actually deploys the infrastructure for the whole set of resources, simply because it's a demo and it's meant to be simple. But unfortunately, I've seen it in the real world as well. So it's not to be discarded altogether. And then all the application will do is to deploy to app services. So it's nothing special. All the applications are deployed via app service deployments, straightforward as that. But whatever happens is always the same, which is once the infrastructure is created, deploy to slot dev, in this case, then to slot QA, or whatever I called it, staging, and then to slot production. This is the most basic. There's no deploy to slot, so it goes straight to production. This is the most straight and simple way of deploying with multiple stages. In Azure, how does it look? It looks pretty much a mess, if you ask me, because everything is within a resource group. There is a huge overlap in resources, a huge wastage of resources. Look at how many database instances we've got here. Again, this is real-world samples that I've seen. So there are companies out there that do it. That said, you have something good here, because you're using slots, hopefully, to switch between environments. Those are not real environments, because if the piece of infrastructure goes down, you lose everything. But still, there is a degree of good things, but it's very limited. Luckily, it's the starting point, because the first stage in my deck is rolling deployments. So I'm not going to cover the linear deployment because it's utter crap, let's face it. But let's talk about some real improvements that you can bring. The first one here is doing rolling deployments, which is the first step, in my opinion, towards deployment maturity. It's the first example of an advanced deployment, but it's very low in the ranking if you think about it, because all it does is to maintain the service available during deployments. So we've all done it, right? We need to maintain high availability. We need to maintain load shapes and load profiles for our users. So we have a cluster. That's what rolling deployment is. But you can do rolling deployments in a smart way. So you have a load balancer that distributes the load between node 1 and node 2. What you can do and what you will do is that you will take one of the nodes outside of rotation. You deploy everything on that node. Once you're done, you do the same on the other node, and then you're back in business. No downtime except for the switch of a load balancer, so you lose a few sessions, effectively. The fact is, this works really well, but in controlled scenarios. The scenario that I can think about is an application that's used for managing the employee's leave. Straightforward, simple database. No real request of uptime, nothing that fancy, but you still want to maintain availability because it's important. And I get it. It's fair enough. I'm not going to design an e-commerce around that, that's for sure. So how does it look in practice? In practice, it looks like this. I'm just targeting a single stage here, but it can be multiple stages. And if you want to do it on-prem, like, I mean, I love the cloud, but on-prem is still all the rage out there. So let's face it, we still have plenty of work to do on on-prem. This comes from my lab, and all I do is running this set of tasks in Azure DevOps pipelines against a deployment group. So a deployment group is, let's say, a boundary that you define where you put in your machines, tag them as a deployment group. You say, OK, this is production. OK? That said, I will only pick out of 2 matching targets in my deployment group one at a time, which means that it's Azure DevOps that takes care of updating the machines, but I'm throwing the load balancer in the mix. So what I'm doing here, first of all, is draining the load balancer. In this case, I'm simulating it with an NLB setup. I don't have a physical load balancer at home, so this comes from my lab. I'm just simulating it with a Windows failover cluster, but it would be the same. You drain connections from one side, and I'm simulating with a one-line PowerShell script where I'm draining all the connection from a single node, stopping the node, stopping the website. It's literally IAS reset stop. I deploy the package, and to deploy a package, all you need to do is to use that task there. It's out of the box on Azure DevOps. You can target it to on-prem. You pick up the zip file created with MSDEPLOY. You're done. That's all you need to do. And then, of course, you start the website, start the node, and it goes on to do the other one. Now, it's pretty much what we do, and I showed you quickly, with Azure App Service deployment slots, because that's the effective match for an Azure App Service deployment. I'm deploying to a slot. I'm using targeting the staging slot, and then I can swap with production. So if I'm targeting production here, and I'm in Azure, of course, being Azure DevOps, effectively an Azure service, what you would do is to use the out-of-the-box tasks, which are more advanced for these scenarios because they are native. In an on-prem environment, you have to build up your own set of constraints. In Azure, you're consuming a service. So the service has already got a clear design choice. This is straightforward, right? It's literally a matter of ticking the box there. Now, the downtime is limited to the switchover, but there are some drawbacks. First one, most important one, is that you only have one production environment to deal with. If that goes down, if that goes lost, you need to rebuild. And then having temporary reduced availability, because you're using one node out of the 2, means that you have higher than average load on the other node, which, again, it's about shaping the load and understanding if you can do it. If you can't, we have other options. So again, it works very well with control scenarios where you can handle the load. The example about the annual leave allowance is something that I faced personally. So I think it was a perfect example for that. Before I go on to something more interesting, any question? everybody's scared about the box that I'm there. I promise I'm not going to throw it too hard. Oh, nice one. I assume that this is working, hopefully. Not really working. Let me give you a mic. Thank you. I was promised the box to throw, but you know. Right. Tell me.
Hello?
Yeah, go for it.
So this is good for binaries, but none of these exist on their own without a database at the back end.
Absolutely.
So how do you do the database to go along with this?
If you got the patience of waiting like half an hour, I will show you.
Okay. Thank you.
The reason why I focused on the web applications, on the binaries, is because usually databases are the last bit that anybody thinks about automating. And then it means that I can keep the interest high. No, I'm joking. It's simply because there are different tools, patterns are different, and effectively there are more commercial tools available for it. So I carved out an example, which I did in the real world, where I did something that was extremely tough, both on I/O and availability, and we managed to make it work in a way that was almost seamless. So more to come on that in a few minutes. Good question, though. So not everybody is sleeping right here. OK, so blue-green. Now, everybody has heard about blue-green deployments, right? Right? OK, are you doing blue-green deployments? OK, cool. One. I got one this time around. It's the land of almost no downtime and more, I reckon. So blue-green is the first real big pattern that should be featured in software engineering books, if I'm honest with you. Blue-green feature a controlled deployment of a clone of a live environment, effectively. So back to the example we had before, this annual leave management system is growing at a pace I've never seen. We still have a load balancer, but now we have two environments. There are different shapes of blue-green. The one that I favored the most is the one that targets blue first by switching to green. And the reason is simple. If you have blue in use and you start deploying on green first, unless you have some safety nets, health checks, you name it, you might not be ensured about its consistency. So yes, it's a clone of a live environment, but how long has been since you used it last? Who used it last? Was it used for any real-world testing in the meantime? Did someone fiddle with it? The list goes on and on. So the first thing you can do is to take a smaller risk, because whenever you have a deployment, you have a risk involved. You take a smaller risk and you switch to what is technically the standby environment. Doing so ensures you that whenever you start the deployment, you're starting on an environment that's consistent. And that's quite important, because you want to maintain availability. So if you do the other way around, and you start deploying over here, or everything is fine, then you switch over, and everything is broken because someone forgot a table from a database, in point, then you need to switch back and pray that nobody started using that application, because remember, no downtime here. So it's actually more dangerous to do it. If you do it this way, your risk is contained. So you start deploying on blue, however you want. Okay, it could be big bang deployment, it could be linear, rolling, you name it. And this is important. The environment should be tested and ready, which not only means smoke tested or running whatever type of automated UAT you like, but it should also be warmed up in case of a web application, or if you have some caching, or whatever requires reactivity from user requests. It should be warmed up, ready to serve connections. Very important, this one. Once you're done with it, you switch over and you sort out green. That's how you do blue-green properly. Also, this is important. Those two environments, they should be physically separate. So you should not use, let's say, one app service plan, or even worse, one app service with 2 slots, but one app service plan with 2 app services. Because if the app service plan goes down, you say cheerio to the whole environment. So you don't do it. You do it with separate pieces of infrastructure. We got the cloud resources, easy to deploy with ARM. We do it properly. That said, again, simple example here, blue and green. I swapped the production cluster preemptively. And again, I'm simulating it on-prem. Then we'll look at the Azure one. Simulating it with the production swap there. And again, it's a simple PowerShell script that fiddles with the DNS. I don't have a real load balancer, so I'm going to do it fiddling with the DNS. Easy, straightforward, and it works. Then I do rolling deployment. So I do that as I did before. And then important, I simulate the node warm-up. The node warm-up, if you want to keep it really, really simple, 36 lines of PowerShell that creates a web request. If the result is 200, then everything is fine. Otherwise, throw the exception and fail the release. That's all you need to do. I also put this into an Azure function. It's on GitHub. It works. Okay? It's effectively, it's simply an HTTP request that needs to return an HTTP return code. If it's 200, everything is fine. Otherwise, go and take a look at it. But that said, this is as simple as it gets to enable quite a complex pattern. So same no downtime approach. You have doubled infrastructure, so more cost. But it is slightly easier to roll back. Because you remember, if it fails right here, when I switch from blue to green, then fine. Straightforward, because that environment was in use already, so I can switch over immediately. And the cost of rebuilding it, which is factored in time, especially within Azure, is limited to an ARM deployment, or Azure CLI if you really feel brave. But that's literally it, or Terraform, again. Questions on this? Because the reason why I put this first is because I've seen so many wrong examples all around where they forget about splitting infrastructure into 2, which means that your infrastructure becomes the single point of failure. And if that goes down, and even within it, Tommy, the mic.
Hello. So I think it was Fowler who said the key thing about blue-green is what you're doing is you're decoupling the act of deploying from the act of going live. So you can deploy at your leisure and then go live in a switch, right?
True.
But that also fits slot swaps.
True as well, but you need to make sure that when you go live, you are actually ready. And that's what saves you in case of a critical rollback.
You swap the slots back? I don't know.
Yes, but when you swap, if you're replacing the binaries and then swapping, you need to make sure that you can swap cleanly and with a single app service plan. If that goes down, you lose it all. You lose both.
You want a larger unit of isolation?
Yes. I mean, Fowler is right. Don't get me wrong. Fowler is absolutely right. I mean, at the end of the day, he invented the term, right? But the fact is, it was done in, I don't remember the year. Over the years, we realized that there were other things at stake. And usually, this is a bigger safety net that gives you more flexibility in case of disaster. I mean, as I told you before, deployment is equal to risk. You need to minimize the risk, so you need a bigger safety net. With Azure, we got so much at our disposal in terms of resources that's effectively so easy as a cup of coffee to deploy a new environment and keep it on standby and have it ready there, potentially by running a new ARM refresh so that it runs the template again and makes sure that everything is up to scratch, rather than risking it and having a single app service plan that's serving 2 slots. So it works, and it's right. It's technically right, but you need to factor in the disaster recovery scenario. That's where it comes from. Good question, though. It's an excellent point, the one you raised. Anybody else?
You did the cache warming on the blue environment after deployment, but wouldn't it be sensible to do that on the green environment before the switchover as well? So you can warm up the caches, you can test it to make sure it's live.
It is the same thing. So let me get back to the chart here. When I start, I'm starting with blue serving production connections.
Yeah.
Then I switch to green, which should be ready, of course. Okay? So green is always a clone of a live production environment. You should always be ready to serve your connections, right?
So how would it have its caches all ready to go?
It should be warmed up in the same way. I'm just skipping the fact that it should be
So
as
you'd have
ready
that
as blue.
step. Right. You'd still have that step in your deployment then.
True, but I'm not deploying actively the new version on an environment that's not tested.
Yep.
That's the difference. So if I deploy straight here, there's still a small chance that the environment was in a leftover state, and even if I deploy and warm up, there might be something wrong.
No, I understood that part. What I was asking is, wouldn't you do your warm-up and test on green before you switch from blue to green in order to do your
Yes,
offline deployment?
absolutely. I just left it out and took it for granted.
For simplicity.
But
Okay.
this needs to be an always ready-to-go clone of a live production environment. So yes, absolutely, should always be ready to go by definition.
Cool.
So I was just analyzing the moment when you actually deploy to it. But yeah, absolutely. I see that taking the box away from the equation helped. Oh, the box is back.
Hello.
Yeah, the box is back. All right, I'll go on then. So now we get on to something more interesting and difficult, because it is difficult at the end of the day. CANARY deployments. So CANARY deployments, they have different flavors of it. There are different patterns in there. Silent launches, progressive exposure, testing in production. They, in my opinion at least, can always be categorized as CANARY deployments because you have a progressive exposure of certain features to groups of users, which could be active users or automated users, and those are not effectively live launches. So from an infrastructure point of view, they are like blue-green, but with an additional environment on top of it. Because the environment, could be called pre-prod or whatever, should be used by a predefined group of users, which you can name beta testers. It could be automated testing suites. It could be anything like early adopters, anything really, which are going to use this early V2 version of your code, like this, for example. So you still have a load balancer, which is now pushing stuff to both environments. And the early adopters will get the V2. The regular users will get the V1. It happens all the time. If you visit one of the, well, pretty much all the major portals, they usually do this in context of testing and multivariate testing, where they test different combination of UI and UX to see which is the one the user is most receptive to. So that's very common. It's actually a marketing tool to verify which is the most effective workflow for a user. So those users should get new features before the general availability of a product. I mean, a well-known example, the Windows Insiders program. At the end of the day, that's all that is. You get an early version of Windows, you test it, it's a few 100,000 people out of God knows how many millions of users of Windows. That's all it is. So how do you get the most out of it? By using feature flags. And there is one tool that I like particularly, which is called Launch Darkly, and hopefully my demo should be up. So Launch Darkly is literally feature flags as a service, which takes out all the effort of creating your own configuration management system and everything that requires keeping track of your feature flags, which can be quite a time-consuming and resource-consuming exercise if you think about it. Because my example here, straightforward, doesn't do anything special. It's just a couple of things. And you see it's not warmed up, so it was not ready for consumption. But it is very simple, okay? So unfortunately, my programming capabilities are very low, and this example has been around for ages. But you see I have a home header here and a sum feature. This actually works. If I recall correctly, this is still working, yes. But if I go on to launch darkly, I can check the usage of my feature flags. Now we'll also look at some code for a difference. So in my system here, I'm only seeing one of the two feature flags that I enabled. Sum is on. Can you see it from the back? Can you see well enough? Okay. Sum is on, subtract is off. The moment I toggle the feature flag, also known as feature toggle, subtract is enabled. This is immediate. And let's say that you're trying to get something that's not authorized. So my application is there, it's running. I disable the feature flag. Someone has got the cached UI or whatever in there. Oops, cannot get around it. There is a reason behind it. There is nothing special in the code except different paths for your code. So let me take the actual code of this thing. I'm using my usual laptop here. The code is extremely simple. I mean, again, I don't write production code, and has been done for aging. So I've got stuff in the controller where first thing I do, I authenticate, and I simulate an authentication. That's really crude, but I simulate an authentication pulling in the properties. So once I'm authenticated, I ask every time I run the controller, yeah, guilty as charged. So whenever I run the controller, tell me the value of sum and subtract, my two featured flags. This is crude. This is not production code. You should never do it like that, but it works in the context of an example. So the first thing you should do is authenticate. Then, if you have feature flags applied by user or groups, of course, then you should say, OK, what's the value of my feature flags? Because the system should know the feature flags anyway. What's the value of it for this user or for this session or for this whatever? And then, OK, visualize the feature flags. The rest of it is not important because the way that works, whoa, that's bad. The way that works is that if the feature flag is enabled, and again, crappy code, if the feature flag is enabled, fine, go and use it, consume it, OK? Otherwise, return, you're not authorized. You track the event in the telemetry, so you can trace back the call from the feature flag system to your telemetry, and you're fine regardless, so you can always track it back. And if you get in here, you don't have visibility, you don't have exposure to the rest of the code. So whenever you hear talking about feature flags, that's simply it. This is simple, this is crude, nothing fancy, but it does the job. And that's what the feature flag system does. Now imagine it in an industrialized setting where you have a proper control panel and you can flip the feature flags on and off. Then it's important to have a configuration that goes across the system. You have your config settings, which might be transformed between environments, all things that we know about. But this is how it starts. It is literally an if cycle and a system that controls a feature flag. If you don't want to use launch darkly, which again I love because it makes something that's time-consuming very simple. If you don't want to use it, then the way of building it is with a couple of libraries that are on GitHub. The most famous one is called feature toggle. And then you build your catalog of feature flags and you read the feature flags every time you need. This works on web applications, mobile applications, desktop applications, whatever. If you have the example of a occasionally connected application, you can cache the flags depending on a default configuration, and so you can action them accordingly. If you don't have connectivity to the feature flag system, you cached it, so the latest known state of the desktop application or the mobile application is that, so that's allowed to run. Questions? Good point. It's a good point. And I'll tell you my way. My way is that if I want to route a certain amount of traffic to version 1 or version 2, I should know how to identify who goes where. So what I'm doing here is to authenticate, bob@example.com. That bob@example.com ends up in a group that's got access to several feature flags. So the load balancer will know, okay, I'm calling, the request is coming in, load balancer and or launch darkly. We'll say, okay, you have access to this. If you have a load balancer, you do it there with 2 environments. If you only have launch darkly in here, or a feature flag system for that matter, code is the same, but you have different paths depending on who is coming into. So your code is acting as a load balancer of sorts, if you like, okay? But if you only use feature flags on their own, yes, it's simply a technique to expose different features. But if you combine it with authentication, it means that you can decide, Matteo doesn't see anything except the standard features, and anybody else would be able to see premium features, because maybe they paid something for it, like Netflix does, where you have different features depending on what you pay. I wouldn't be surprised to discover that there is a feature flag system in place and not different systems that cater to different tiers. It's an example, okay? So you could have nightly builds on an environment, which you can only get to if you have corporate ID, and everybody else will go to the production one. Or you might have beta versions around, which are identified by different agents. I mean, there are all sorts of ways of differentiating between the 2 groups. This is an example that it's a bit of a catch-all because it has controlled exposure. It's got the way of authenticating and then grouping the users, and it is simple enough to show it in 5 minutes. Because I don't like demos that are too complicated. That's just the wow factor of the technology. There's nothing wow about this. Excellent question, though.
Sorry, not a question, but kind of adding to the conversation. When you talk about feature flags, it's good to use feature flags when something is in development, but you should also talk about the lifetime of a feature flag. Otherwise, your code becomes littered with if statements.
Yes.
So you might be trying a feature flag for an experimental feature or a new version of something.
Absolutely.
But eventually that becomes standard production, and you have to retire that feature flag to make it a standard thing.
We'll touch on that in a minute. That's absolutely a good point. Technical debt is always at risk of exploding if you don't cater for feature flags. It becomes a massive if statement, and that's true. Because once you get to production, it means that everybody should have access to a certain feature set, unless you have a different model, which means that what used to be feature flags should be refactored in being the default on state. But yeah, absolutely, good point on that. And it's important the trade-off that you're making with this, because you're introducing something that's silent or not as used as it might be. So there's always a risk of having an experiment, it works for someone, let's leave it there for a while, now you go on different pastures, and eventually you forget about that, and it's always been like that for ages, and then refactoring that can become quite costly. Anybody else? Might be the first time I've got time to do everything on the session. So yeah, with feature flags, I just skipped ahead, honestly. You can selectively enable or disable features. And it should be the first code you write for a new feature, because it means that you can quickly deploy to production. So yeah, the example in the topology, with a feature flag, you can decide that. It also provides a kill switch, which is good, because you should have a master feature flag that says, OK, turn everything off except potentially the essential services or whatever you know is not impacted by that. So it's easy in case of trouble. OK. Problems with V2, everybody, including early adopters, back into V1. A/B testing, what I was mentioning before. So regular user version 1, early adopters might get 60% version 2.1, 40% version 2.2. Then evaluate the results and collate for potentially marketing purposes, reliability researches as well, those sort of things. And then what I consider the most extreme example of all, which is shadow deployments. Shadow deployments is silent releases on not fully working components. So when you do shadow deployments, you have two environments, again, both with the V1 in this case, but the green environment has not only got the V1, but it also got a new DB schema, which is a work in progress, and a beta API. Everything in production still. So an example of a database schema change in practice, hence the question before, if we start with this database, this extremely complicated database, the request might be of a new feature which combines the color and the shade. OK. And we have an API, of course, in front of it. So sprint number 1, you deploy the schema change. This is in production, again. Nobody's using it. Nobody's consuming it. It goes on. Sprint number 2, business logic, API. I'm keeping it simple, not involving architecture or anything. The new code is behind the feature flag. So it's not used by any actual user. It's off, literally off. The reason why it's done this way is because this approach enables you to validate your deployment pattern and validate that you're actually deploying it right with the expected results. Once this is done, sprint number 3, so third iteration, you start enabling some users to the new API via the feature flag system. A user could be a real one again, beta tester, early adopter, whatever, or testing procedures. So you want to try some automated UAT. You might want to try spec flow in a pipeline. You might want to try something like that. You can do it because you can identify the user in production. So I'm testing it, and I'm testing it only on a subset of data because it's an automating testing suite, which means that I've got control over what I use. And line number 8, well, line number 8, ID 7, becomes the actual end product. Sprint number 4 establishes a migration strategy because this is simple, okay? It takes a fraction of a second on any database worth its name. But if you have a multi-terabyte database at stake, it's not that easy. So in this case, you should establish a migration strategy, which could be a script that runs overnight before a release. So you know you have a certain amount of time on release day. You are confident that you can do it because you tested it in other environments. OK, it's fine. It just takes a couple of hours. I don't want to do it during office hours. So it just translates the different column values into the new one, or something more complex like a job that runs continuously for 30 days, and every day does a delta of the data. So if you have that situation, you can have this job, which keeps updating and checking the percentage of the update, and every day you will always have a smaller delta. At the end of the day, well, at the end of the day, no pun intended, at the end of the process, you might end up in a situation where you have a delta of like half an hour. And so you can be confident of running it once again and then switch over. Anyway, what's important is that you're in a situation where you are stable and happy with migrated data. That said, this is still not in use because you need to make sure that your database, being a database-first application, is in a good enough state to be consumed by real users. So again, testing, validation. I'm taking it for granted here. If you're doing shadow deployments, you should be doing proper testing onto it, okay? Eventually, once you're ready, you can flip the feature flag for all your users, because here you're still under a small subset of users, so you can expand that subset to include real-world tester. But you should only do that in a situation where you're confident to do it, to expose it to some users. And then, what was the Sprint #2 API becomes the new unified production API, hence the conversation that we had before about technical depth and including it in the new default on state. Now, this is not easy. I don't want to say it's difficult because it's not that difficult, but it's not easy. And obviously, if I no longer need the original columns, I can remove them. But would you do it for retrocompatibility reasons? I personally would not do it unless there is a solid requirement to do so. Space, but storage is cheap, or if you have new constraints that are coming in, so you need to revamp your database structure. But yeah, usually you don't touch what it works. Again, resistance to change, right? It works, it's been there for ages, fine. You can keep it. Still, you can drop it, and you need to be sure by testing it that it's fine even without those columns. So feature flags, again, reevaluate all your feature flags, evaluate all the code paths where those columns were consumed, and make sure that it actually works. Now, the rollback is possible anytime via scripting. You cannot do it automatically, especially if you have a job that runs deltas. But what you can do with this is something interesting, like running real-world tests. By real-world, I mean on the real production application, you have real load shapes, real production usage, and you can test with your suites with a certain degree of probability how the new API is going to behave. Because the system which you're consuming is already under live usage. You don't have to wait for 5 o'clock Friday afternoon to test it. You just do it. It's testing in production. You can potentially create stuff like a mock service that consumes the new bits in production before you release them to your users. So you have a mock service that runs a series of calls which simulate an average production user. Again, you have all sorts of combinations here. You can do load testing under real circumstances. So if it's an intensive load API, you can test timeouts, responsiveness, graceful degradation, those sort of things under real world, because you're using the live production system. So you can do it. And then how is it different than any testing environment? Well, you're testing in production. So you're testing a system under a real load, so you can immediately spot stability issues the same way that the user will affect it. So if you're running virtual load tests with JMeter, you can easily spot, if you have 10,000 users simulating a load on your new API, you can immediately spot if there is something that can go wrong. On the downside, it's the most expensive of the lot, and it's the most complex to set up, because now the systems architecture is driven by the pipeline. The pipeline shapes the way you bring new features into production. Like every major system you use, I'm fairly sure that there are a degree of features that are not available yet. So it's quite the top of the range when it comes to practices, but there are all sorts of examples out there. So handling breaking changes, my point before about dropping the two columns, becomes more difficult. It's always live. It's always running. You always have continuous testing on it, but dropping something and having a breaking change becomes difficult. Questions on this? I mean, this is fun to implement because it's kind of new ground. It's very much a greenfield approach, and it can bring on big results because you basically, well, you still have testing environments, but then you can bring the deployments to the extreme and try new approaches that just a mere percentage of companies out there do. Did I knock you out? Okay. The last one that I added is liquid environments, also known as no DTAP. DTAP stands for Development, Testing, Acceptance, Production. That's a concept that was brought up by a fellow MVP a few months back. And he's actually very much right, because for ages, the industry used this DTAP approach. Linear development, everything goes in there, it's tested. Once it's deemed fit for QA, it goes on to testing, eventually acceptance with manual testers sometimes, yes, and then production. But in the cloud world, does it really make sense? Does it make sense to have 4 resource groups running with a good 70% at least overlap of resources with different load shapes and different consumption shapes? Does it make sense? Cloud is pay as you go, right? So that means that you can quickly snap up an environment, and you can quickly turn it down or dispose of it altogether. So if you use cheap and disposable environments, containers, just making one name up, but it could also be platform as a service, doesn't make any difference. How long does it take to spin up an app service plan? Minutes. So it's much easier to provision and deprovision environments. Straightforward, right? So with liquid environments, you can do targeted operation at scale, like this simple example here, which I think is very fitting, because once I have a new bit of code that goes on, right? Why should I have permanent environments stood up? If I take the testing example here, I could have UAT, so acceptance testing, and performance testing running at the same time on environments that can be eventually disposed of. Because if it's simple enough and it's granular enough, so I'm not talking about the big monolith here for obvious reasons, but if it's simple enough and granular enough, what I can do is deploy my environment on the fly, deploy the same bits, run JMeter in this case, collecting the results, and then dispose of the environment. What should I keep it for? This is why it's called liquid. You spin up and down as much as needed. And if you have several microservices, several components, all sorts of things, it should be easy enough to be able to spin up and down, like you scale out or you scale up, right? So we are at a cloud user group, so we should be all familiar with the concept of scaling. This is the concept of scaling in place for environments. So you don't really need to have a permanent environment which is dedicated just for testing that service. You can spin it right on the fly. Use it, dispose of it. It's the same philosophy as a Docker container, for that matter. So I think this is something that's going to have legs, and is going to be used more and more in the future, because it's something that you can do straight away today. Let's see if my release failed or succeeded, actually. It did, which means that I run my stuff over here, and I should get, in the summary, my test run. So my summary is there. My test run is there. I've got some results from my test run, but I don't care about the environments I ran it for because it was just a test. It's called test for a reason. As long as I get this, and I'm confident in the automations I built, then I'm good to go. I don't need a permanent performance testing environment or UAT environment for that matter. So that's something you can do easily. It's more down to the architecture and the way the solution is structured rather than a technology problem. This is not about technology, nothing at all. Because you can do it with Azure DevOps. You can do it with any other platform, Atlassian stuff, easily. You want to use GitHub and you want to use something else, go for it. Doesn't make any difference. It's just about how you structure your process. And I'm not saying that everybody should be doing it, okay? Because if I take a monolith that takes 2 hours to compile and 4 hours to deploy, including the database, then no, clearly. But if I'm using something nimble enough to go on platform as a service, why not? Because an example that I can bring on is big company. And again, I'm making it up, but it's a plausible example. If you use an ASE, so an isolated app service, you can do it. It's even easier. You have your ASE. You can spin up and down on the fly up to 100 app services. So you can consume the same plan, well, the same piece of infrastructure with different plans, but the same piece of infrastructure, and you can do this easily, even easier than actually re-spinning out more things. If you're using the public cloud, even easier, because you just run your ARM template or your cloud formation, and you go for it. So I think this is going to be what the future in terms of deployments will bring us to. Because it is so cheap between containers and platform as a service to deploy a new environment that I don't see the point anymore having something that it's 99% idle and used maybe once a day, if I'm lucky enough to be in a place where they test once a day. Questions? No, absolutely not. Unless, there is always a catch on this. If you're doing 200 deployments a day, you're clearly at the maturity level where you're able to replace your services quickly. So you're doing it, right? You're doing it in a different way, in a different flavor, but you're in a position where you can replace a service on a snap. So it's the same concept. This is just a way of introducing it for slower paced organizations. If you're doing it 200 times a day.
I'm just trying to, if your aim was to do that, sorry. What am I supposed to do with this? All right. So
you took all the fun out of it. I wanted to try.
If your organizational aim was to achieve that, would you recommend this? Because it might turn up as a hindrance in terms of what you're putting in.
You might turn, sorry.
Because if you put this in place, but your aim is to have a lot of deploys per day, I mean, would you recommend? I mean, I'm trying to say, if I start using this, then I might shoot myself in the foot because my aim wasn't that to begin with.
This doesn't cover production.
Okay.
This is for non-production. Okay, so in my example, but again, it's an excellent point, the one you bring. If you're in a position where you can spin up and down different environments on the fly and different services on the fly, you're doing it already. What you're doing here, if the Wi-Fi collaborates, over here. So the situation is that you have a production area where you might do 200 deployments a day. But if you want to quickly test something that needs to go in production with a certain degree of confidence, instead of having fixed environments where they're idle 99% of the time, they don't do anything because you're doing microservices, you're doing small chunks, and you're moving things quickly on the train, you spin them up on the fly just for what you need, mock services, smoke testing, all the possible testing automations that you might think of. You got a good degree of confidence, you move on, and that's disposed of. So yes, you can do it. If you can handle this process for 200 services, fine, do it. Don't see why not. I just don't see the point of fixed development environment, fixed testing environment, fixed acceptance environment, which is idle 99% of the time, unless you have manual testing or stuff like that. No problems. Anybody else? All right. So for something completely different now, because, I mean, it's a lot. So I think the most success you can get when adopting something new is about people, not technology. So we only looked at technology as of now, but it's people that make the systems work. So you have organizations, you have teams, you have groups, you have stuff that make everything work. So a few things to keep in mind, from my point of view, to make your life easier and simpler. The first one is to have consistent ACLs. So you don't have someone fiddling in with your systems or with different stacks where it takes half an hour to add someone in before the permissions replicate. Don't do it. We cannot advocate automation and then waste hours and hours on handling permissions. Doesn't really make sense at the end of the day. I'm happy to wait for a long time for replicating those permissions. I've seen things where it takes a couple of hours to replicate permissions because of group policy. Fine. But don't waste your time jumping across 6, 8 different systems. It's not effective. So using groups, I mean, I take it for granted really, but sometimes it's worth mentioning it, makes access management easier. And use the groups as a single source of truth. So forget about users. A user ends up in a bucket. It's the bucket that matters. Keep production as a separate stage, so treat production in a special way, unless you feel confident not to do so. But if you have a linear production separation, it means that you can be more confident and it can come in handy. So production should be really the last place where manual access should be your last resort. If you look on the Azure DevOps data protection document, if I recall correctly, they mentioned that if they need to access data contained in Azure DevOps, they use workstations which are locked down with conditional access given on a time basis because of the sensitivity of going onto a live production system with a human being. So it's always the last resort. Keep it separate as it acts as a first encapsulation stage if you have different patterns and things that require multiple clonal productions. There is always an alternate production, okay? So there's always somewhere where you can kick the tires of your system before the switchover. We've seen plenty of patterns where there was an alternate production of like a live standby or anything. So alternate prod is a thing. And alternate and production, like app services and slots, same example here, they should always be conceptually the same. And with production as a separate stage, all the heavy lifting is done in this pre-production of sorts. Because if you think about my blue-green example, it's when you deploy in the first environment that you do all the heavy lifting and you verify that everything is fine. Once there it's done and dusted, then you will be very confident to move on. So it's the first pre-prod is maybe not the correct term here, but the first stage is where the magic happens. Also, the typical stuff, always worth mentioning, parameterize setting and populate them at deployment. So the settings should not be version in the repository. It's a security issue because it's not just feature flags, but it's also credentials, personal access tokens, secrets. I've seen it all. So remember that. And also, you want to be able to edit your settings by the pipeline. That's something that sometimes is taken for granted, and I think it's very powerful. To have a pipeline where you can deploy your system, but you can deploy different configurations of your system based on the setting of the pipeline you're using. So if you trigger a pipeline and you specify a configuration mask or whatever, that configuration setting would mean that you get a certain flavor of your pipeline, of your system via that pipeline. So that's something that's always worth keeping in mind. And also, remember that consistency is granted because nobody's touching your configuration files. You're handling the configuration via the pipeline, so there's going to be no manual access to the environments. So I'll wrap this up because I think it's very long. And I think for the first time, I actually had time to go through every bit without rushing it through. So it's not just for unicorns. There is something for everybody, regardless of size, regardless of complexity. And regardless of what your application does, it's always how you ship it that matters. So I think it's one of the biggest things that we discovered in software engineering for the past 10 years, maybe just second after continuous integration. So it is extremely important, and I strongly recommend you to spend a couple of hours to just see if anything can come in handy and improve your process. So package, automate, and go wherever you want, really. You don't have to do no DTAP from day one. If you have a linear pipeline, you start kicking the tires with rolling, that's going to be a massive improvement already. Final questions? I'm going to be around anyway. All right. Slides are already on SlideShare, so if you want to have a look at them, feel free to grab them. Very happy for that. And thanks a lot.
Big ass mic, this. Thanks, Matteo. Really great talk. Just a few things came to mind. When you were talking about toggling, I'm sure some of the audience are as aged as I am in Azure, and remember web roles and toggling from into production on Classic, and then you showed deployment slots within web apps.
Yeah.
What do you think's next for Azure?
It's a good question. I think with the focus there is on Kubernetes and containers, most of the new big developments will be spearheaded there for obvious reasons. But again, if you talk about those sort of things, it's all about patterns and approaches. So it's nothing that's not going to be possible to different types of applications. If you think about it, functions are nothing more than a pattern, an architecture on top of something that already exists. We already have all the technology bits and pieces in place. It's just about how we group them together and we consume them. So as long as we are within the cloud, with the flexibility of the cloud, then it's going to be very easy to trickle down all the new developments.
Okay. The other question that I had is with the things that I do every day, I use Azure DevOps every now and again, but not consistently. And I find that I still have to do quite a bit of work myself in scripting.
Okay.
How do you think this is going to evolve in terms of tasks that can basically make this infrastructure as code and deployments as sort of script-free as possible in the future?
So if I'm honest with you, I always tend to use as many tasks as possible, even from the marketplace. And I try to decouple the problem into as many tasks as possible, just because it reduces the maintenance overhead. But with YAML pipelines and multi-stage release pipelines in YAML, you basically have the whole pipelines as code pattern implemented in Azure DevOps. So it's going to be much easier to actually introduce this. And even if you have a script, or if you have different sections that you might need to mix and match, you get templating on there. So you can create your template and do stuff like dynamic execution. So you pass an X number of parameters, and you get an X number of results. That's something that was not possible before. You could not, with the traditional pipeline, with the classic pipeline, you could not easily loop. You could not easily create something like that that's effectively generated.
Like control flows?
Yeah.
Okay.
So it was a flow. It was a control flow because you had all the conditions that you might think of. But templating and looping were the two missing bits that now we've got with YAML. So you can really go on and go right.
Fantastic. Thank you. So Matteo's going to be here afterwards for a few questions, if any of you think of anything that you want to ask him. Is Andy around anywhere? Want to grab him finally? Just to, about a month ago, Andy made an announcement about, or was it 2 months ago? I forget now, time all melds in the Microsoft world. About the Azure Fund. Just recently, Microsoft stopped supplying food. So what we're going to try and do is raise money through this fund, through user groups. And I just want to say again that if any of you works for employers who are interested in marketing activities through the range of user groups that are going to be subscribing to this, we've got a very, very organized approach to raising money now and then distributing this to user groups all across the country. So even if you can't answer this now, bear this in mind. Andy's at the back, Andy at elasticloud.com. Please think about this when you go to work, and because we are trying to do something good here. There are you know, a lot of user groups that are less fortunate and don't get free spaces and have to pay quite excessively in different parts of the country. So the idea of this fund is to supplement them as well as our beer and pizza. Anyway, thank you all for coming, and feel free to hang around afterwards and speak with all of us. Thank you.
On a